Hello and welcome to this presentation of some new exciting features in IDEA StatiCa. It's the 3D Detail beta. The agenda for today is to look at the theory, and we will look at some general footings, walls, and this link between connection to the 3D detail. Now, the 3D CSFM, also called the compatible stress field method, is implemented in the detail application, and it extends the established CSFM into a third dimension, resulting in a fast and code-compliant solution that is primarily applicable to the everyday engineer, giving unique new ability to safely tackle the complex details of concrete structures. 3D CSFM defines the concrete behavior based on the Mohr-Coulomb plasticity theory for monotonic loading, and the method considers principal concrete stresses in compression and reinforcement stresses at the cracks while neglecting the concrete tensile strength, except for its stiffening effect on the reinforcing. The reinforcement bars are linked to concrete volume finite elements through bond elements, allowing for slip between the concrete and reinforcement. It should be noted that 3D CSFM is not suitable for simulating plain concrete due to the absence of tension, which may result in misleading deformation and model divergency. Generally, the Mohr-Coulomb theory includes two fundamental properties governing the evolution of the plasticity surface in compression and partially in tension. So the internal friction angle phi and cohesion parameter c. 3D CSFM assumes a zero angle of internal friction, leading to a conservative design due to the plasticity surface, resembling the CSFM model, which is independent of the first stress invariant. This new feature, it's augmented CSFM because it extends to the 3D volume elements with 1D reinforcement bars. So you can calculate steel to concrete, concrete to concrete anchoring. And in this first stage of releasing, the 3D CSFM only ultimate limit state is supported. So the strength and anchoring check is the one that you will get. Let's look at a demonstration of a general footing. Let's start with a concrete block. You can choose between a rectangular or some other shape, and then you place the supports. They can be the whole surface or a polyline. We can even input or import some shapes or surfaces. And then we can apply the base plate, edit the parameters, put in some anchors, and then we can apply some loads to the anchors. So we can choose between surface loads, point loads, and group of forces. For these tension anchors in tension, we will place some point loads, and in the rest we'll place some compression, some group forces. So next is the reinforcing. So we will edit and input the parameters for the reinforcing to have it on all sides and in all directions. And here's the load combination. It's one for ULS. Now we can run the code check, and we can see the stress flow and the strength, the stresses in the concrete and in the steel for and the anchorage, and then the deformations. And the report as well, you will recognize it from the steel module. It has been updated a little bit, and it's a really nice and condensed report containing all the information you need. Yeah, so let's look at walls. You can also do walls with eccentric loads and eccentric walls. You can see it in the picture here. I will also show a demonstration of it. You can have orthotropic material properties. You can also import with the DXF format, both elements and bars. And there has been implemented some unique mesh formulation for computational speed. And this is also limited to only ultimate limit state. So let's choose a wall and create the project. And I will hide the rebars in the view. And now we can choose from editing the wall that we have here or importing some DXF file. In this case, we will just edit the wall we have here in the program, and we will add another wall and connect it to the top of the first wall. And we will increase the length so it will correspond with the first wall. Next step is to add opening. And here we can also choose from rectangular, circular, or polygon. And now we can add some supports. There are different types of supports as before. We will choose this point-bearing plate and place it on the second wall. And for the load cases, now you can also put out-of-plane forces, point loads or line loads. And in this case, we will just have some loads in the gravity direction. And now we can put in some rebar assembly. So let's choose a group of bars and connect the two walls together, like so. And we also need some rebars around the opening, this new opening that we made, and have the diagonal bars overlap with the horizontal and vertical. So we can run the code check, and you can see the results for the ultimate limit state. So we have the stress flow, the strength, where you can again look at the stresses and strains of the concrete and reinforcement, and the deformations. Quite important to have a look at that as well. And another cool feature that is new with this release is the connection between the connection application and the 3D detail. So it's enabled for anchoring only. You can then export if you have both the concrete and the steel license available, because first you have to model the connection in the steel part and then transfer it over to the concrete part of IDEA StatiCa. So the base plate plus the concrete block is exported, and the forces from the welds are exported into detail. Anchors are loaded independently on the base plate. Let's do a demonstration. So in this case, I have a footing. It's a column with a base plate connected to a concrete block. I have some loads, and in this case, if I run the code check, it will pass the code check. We can see it here. We are well within the limits. But if you have a case where the base plate is quite near the edge or the concrete foundation is quite small, I can show you what will happen. For example, if we have a concrete block that looks like this, I can run the code check, and we can see that the anchors are failing. The check of the anchors are failing. So we can go into the code check in detail and look at what causes this failure. And in this case, we can look at the corner anchor and expand the code check. And here we can see that the anchor tensile resistance of the anchors itself, it's okay. It's within the capacity. But when we look at the concrete breakout resistance of anchors in tension, we can see that it's utilized above its limit. So in cases like these, we can do a more detailed check of the concrete in the 3D detail application. So I will go back to the design window, and if you noticed, we now have a button where you can export the results from IDEA StatiCa connection to the detail application. So I will press it and save it. And now I have the concrete block with the base plate and anchors in the detail application. So this is a quite cool new feature. And here you have the possibility to check the concrete more in detail with reinforcement. So if we have a look at this, we can see that the block and the base plate and the anchors are the same dimensions as in the connection application. Yeah, here we have the base plate, and we can also edit the supports if you want to have some spring supports corresponding to the soil on the building site. So in this case, I will update it. And then we have the 4 anchors, and I would like to have a bend in the anchors. These are cast-in-place anchors. You can also choose to have some adhesive anchors if you want to do that. And we can have a look at the load cases. So we can see that all of the loads transferred through the weld to the base plate is here. And also the loads transferred from the base plate to the anchor bolts, they are here. So for this anchor, we have 80.3 kilonewtons, and this one is 40. And if we jump over to the connection application and look at the bolt forces, we can see that they are the same. So these forces you can review if you'd like to do that. You can see all of the forces transferred from the welds to the base plate. It's 152 of them actually. And you can also look at the force group from the anchors. It's here. And then there are also some point loads on the anchors. And here is the ULS load combination that we have defined. So let's move on to the rebar assembly. We will input some group of bars, and we will edit the diameter and the material. And now we will change the definition and what surfaces the rebars are going to be on. So we will set it to these parameters and define the edges. And I also want to complete this rebar with some bends like this. And now I can copy this operation, this group of bars, and I can simply just switch out the surface. Now we have it in the other direction. And at last we will finish the third group of bars. We'll copy this, and now we will do it like this, and on edge 5. So now this foundation is finished. I can go ahead and do the code check. Before I do that, I will switch out this multiplier of default mesh size to 2 to save some time on the analysis. And I will hit calculate. So the results are here. We have green check marks in this case for the ULS load combination. So we can go over to the check tab and review the results. Here we have the stress flow, and we can look at also the strength. We can look at the mesh, and in this case the stresses for the concrete or the reinforcement, and we can look at stresses for each and every anchor and so on, like this. We can also look at the anchorage and switch between different results. And at last we can also have a look at the deformations. Okay guys, remember that this is still in beta in version 24.0, but still I hope you found it useful, so thanks.